Hi friends, this is Naresh. In this class, I am going to explain about engineering mechanics. And today's topic is moment of inertia of an L section. In this video, I am going to explain about how to locate the centroid of an L section and as well as and how to determine the area moment of inertia of an L section. Before going to the topic, first of all you have to know the fundamentals about centroids and area moment of inertia. First diagram refers a solid rectangle having dimensions capital B and height capital D. CZ refers centroid or center of gravity of an rectangle, and it lies at a distance of base by 2 from y-axis and height by 2 from x-axis. The centroid or center of gravity of an rectangle lies where its diagonals meet to each other. Therefore, CG, the axes at a centroidal point are called centroidal axis. So, GX, GY axes are called centroidal axis. XX and YY axes are called reference axis. For a solid rectangle, the area moment of inertia about centroidal x-axis, that is IGX. Moment of inertia about IGX. IGX equal to BD cube by 12. Base B into depth D. D power cube divided by 12. As well as moment of inertia about centroidal y-axis, that is IGY. IGY equal to dB cube by 12, where I refers inertia, and the units of inertia is mm power 4 or meter power 4. That means length per power 4. Length whole power 4 is the unit for inertia. Similar way, second diagram shows the hollow rectangle having base capital B and height D. Capital B and capital D are the dimensions of outer rectangle, as well as for inner rectangle the dimensions are small b base B and small d for depth or height of a inner rectangle. Therefore, the area of a hollow rectangle equal to area of a outer rectangle, that is capital B into D, minus area of a inner rectangle, that means small b into D. So this is capital A equal to BD minus BD is the area of a hollow rectangle, where for solid rectangle area A equal to B into D. Now moment of inertia about centroidal axis IGX, IGY are same. First of all, you have to note down the inertia of solid section, that means outer rectangle BD cube by 12, and you have to subtract the value of hollow section from solid section. Therefore, I written here negative sign. Negative sign refers hollow sections. Similar way for triangular sections. This triangle shows the equilateral triangle or isosceles triangle. This triangle is right angle triangle. Capital B is the base of a triangle. Here also capital B is the base of a triangle, and capital H, here capital H is the height of a triangle. The centroid of a triangle lies at where its median lines meet to each other. Therefore, the centroid of a isosceles or equilateral triangle lies at a distance of base by 2 from y-axis and h by 3 from x-axis, where area of a triangle A equal to half into base into height. Now igx moment of inertia about gx axis, igx equal to bh cube by 36. Similarly, moment of inertia about gy axis equal to hb cube by 36. Same formulas for right angle triangle, but the centroid lies at a distance of base by 3, 1 by third of base from right angle corner, and 1 by third of height from right angle corner, as well as 2 by third of base from sharp corner, and 2 by third of height from top apex point. Okay, now coming to the another model, that is solid circle. This, it is a solid circle and it is a hollow circle. For solid circle, capital D is the outer diameter of a circle and capital R is the radius of a circle. So therefore, from center point to outside circumference, the distance is called radius, whereas the distance between from here to here is called diameter. So area of a circle, area of a solid circle, A equal to pi r square, or pi by 4 d square. For inertia, the given circle is symmetric about gx and gy axis. Therefore, the value of igx and igy are both are equal. Therefore, igx equal to igy equal to pi d power 4 by 64. Please correct it. This is pi d power 4, by 64. There is a small mistake here. Similarly, for a hollow circle, outer diameter of a hollow circle equal to capital D, and inner diameter of a circle, hollow circle, is small d, and capital R is the outer radius, small r is the inner radius. So therefore, area of a solid circle, sorry, this is also area of a hollow circle. Area of a hollow circle, A equal to pi of outer radius square minus inner square, and igx igy both are equal because it is symmetric about gx and gy axis. Therefore, igx equal to igy equal to pi of d power 4 minus d power 4 d divided by 64. That means moment of inertia of an outer circle minus moment of inertia of inner circle. For semicircles, the centroid lies at a distance of 4r by 3 pi from straight edge, and r minus 4r by 3 pi from curved surface. Okay, and similarly, capital R from y-axis. The area of a semicircle is capital A equal to pi r square by 2. Pi r square is the area of a solid circle, complete circle, where it is a semicircle. Therefore, capital A equal to pi r square by 2. Now, the moment of inertia, here the centroid is symmetric about y-axis, gy axis, but it is unsymmetrical about gx axis. So therefore, the moment of inertia about gy axis equal to igy equal to pi d power 4 by 128, and moment of inertia about gx axis equal to 0.11 r power 4, as well as for moment of inertia of an moment of inertia for a quarter circle. The centroid of a quarter circle lies at a distance of 4r by 3 pi from right angle corner. Here also from this side also 4r by 3 pi, 4r by 3 pi from right side, right angle corner. Whereas from curved surface, r minus 4r by 3 pi, r minus 4r by 3 pi. So it is here also the value of igx and igy both are equal. That value equal to 0.055 r power 4. Here area of a quarter circle equal to 1 by 4th part of area of a solid circle. Therefore 1 by 4 into pi r square. Now coming to the problem, determine the area moment of inertia. Please note down. Determine the area moment of inertia of an unequal angular section of 80 by 100 into 20 mm. So here diagram is not given, only dimensions are given. So you have to draw the angular section. Angular section means L section. Okay, angular section means L section. So you have to draw a shape of L shape. L shape having dimensions 80 by 100 by 20 mm. So now I am drawing the diagram of L section. Please observe carefully. So this is the shape of L. Now the height, first dimension, the first dimension refers height of a L section. So height of a L section equal to 80 mm, and second dimension refers base of a L section. That means base of a L section equal to 100 mm, and the third dimension refers thickness of a L section. So this is 20 mm, this is 20 mm. So thickness of a L section 20 mm. Now this is the diagram for a given question. Now how to determine the moment of inertia of an L section. Here first of all you have to calculate the value of centroid. That means you have to locate the position of centroid. After that you can find the area moment of inertia. So first of all you have to split up the given section into some small sections. So first of all I am taking the bottom rectangle as section 1 having dimensions base equal to 100 mm. That means this is I consider as section 1. Therefore base 1 equal to 100 mm, and height d1 equal to 20 mm. So from diagram, now I consider the vertical rectangle as section 2 having dimensions height of a second rectangle d2 equal to, from here to here the distance is 60. From top to bottom the height is 80 mm. So therefore the height of a second section d2 equal to 60 mm, and base of a second rectangle b2 equal to 20 mm. So these all are dimensions for individual rectangles. Now in next slide I am going to explain how to locate the centroid of L section. First of all you have to consider a reference axis. So therefore I consider a x-axis at the bottom edge and y-axis at the left side edge. So x and y-axis are reference axis, and this point is origin. Now coming to the areas, the area of a bottom rectangle A1 equal to base into height, that is B1 into D1. So area 1 equal to B1 into D1 equal to 100 by 20 equal to 2000 mm square. 2000 mm square for area of a bottom rectangle. Now area of a second rectangle, that is a vertical rectangle, equal to A2 equal to base B2, base B2 into height D2. So A2 equal to B2 into D2, that is equal to 20 into 60 equal to 1200 mm square. So A2 is the area of a vertical rectangle. Now I am drawing the reference axis. Now to locate the individual centroids, you have to draw the diagonal lines to locate individual centroids. So I am drawing the diagonal lines where C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis. So x1 equal to half of the base, that means 100 by 2 equal to 50. So from here to here the distance is 50. From previous slides already we discussed about some about centroid formulas. So from that diagrams I written here x1 equal to half of the base, that means x1 equal to 50 mm. Now y1 from x-axis, the vertical distance between centroid and x-axis is y1 equal to half of the height, that means for the height of a bottom rectangle equal to 20 mm, so therefore half of the height equal to 10 mm. So y1 equal to 10 mm. Now I am drawing the diagonal lines for a second rectangle to locate the centroid C2. Therefore here C2 is the centroid of a upper rectangle at a distance of x2 from y-axis. From the distance between y-axis and centroid is x2 equal to half of the base of a second rectangle, that means base by 2 equal to 20 by 2 equal to 10. So from here to here the distance x2 equal to 10 mm. Now y2 from x-axis, the distance between centroid C2 and x-axis is y2 equal to the height of a bottom rectangle plus half of the height of a vertical rectangle, that is d1 is the height of a bottom rectangle, so d1 plus half of the height of a top rectangle, that is d2 by 2. So d1 plus d2 by 2 is the value of y2. Okay, from here to here half of the height, from here to here height of a bottom rectangle. So therefore I written here y2 equal to d1 plus d2 by 2. Okay, from diagram x1 equal to 50 mm, y1 equal to 10 mm, and x2 equal to 10 mm, y2 equal to 50 mm. In next slide I written these values in tabular form. So these are the section numbers: section 1 for a bottom rectangle, section 2 for top rectangle. These are the dimensions. So b1 d1 are the dimensions of bottom rectangle, b2 d2 are the dimensions of top rectangle, whereas the area of a bottom rectangle a1 equal to 2000 mm square, a2 is the area of a top rectangle, that is 1200 mm square. X and y values are x and y values for centroid, and whereas igx igy are the area moment of inertia about centroidal axis. Okay, igx refers area moment of inertia about centroidal x-axis, whereas igy refers area moment of inertia about centroidal y-axis. Okay, for rectangular sections igx equal to bdq by 12. In previous slide already we have discussed about these formulas. Therefore igx equal to bd cube by 12 and igy equal to db cube by 12, and substitute the values of b1 and d1. you will get the answer igx1 igy1. Similarly igx2 igy2. Okay, first of all you have to locate the centroid. So from standard formulas, x is the distance of centroid or center of gravity from y axis, and yc is the distance of centroid or center of gravity from x axis. From general expression, xc equal to a1 x1 plus a2 x2 by a1 plus a2. Here a1 a2 are the individual areas. The total area of a L section equal to a1 plus a2. Okay, therefore answer x equal to 35 mm. Similarly yc equal to a1 y1 plus a2 y2 by a1 plus a2, and answer is yc equal to 25 mm. So xc yc are the coordinates of the centroid. So here this diagram refers the location of centroid. This is x axis, this is y axis. Here C1 C2 are the individual centroids, whereas CZ is the centroid or center of gravity of an entire L section. So at a distance of xc from y axis and yc from x axis. Okay, gx is the centroidal x axis. Similarly gy is the centroidal y axis. Okay, from parallax theorem or transfer theorem, already we know that area moment of inertia about xx axis, about base, that means about base, equal to ixx equal to igx1, that means moment of inertia about centroidal x axis, plus area 1 means area of a bottom rectangle into yc minus y1 whole square, plus igx2 means moment of inertia, area moment of inertia of an second section about centroidal x axis, plus area 2, area of a second rectangle into yc minus y2 whole square, where yc minus y1 yc minus y1 yc minus y2 to refers the distance between two parallel axes. Here gx and xx are the two parallel axes. Similarly gy and y axis are parallel axes. Therefore yc minus y1 is the distance between two centroids, that means cz and c1. The distance between cz and centroid c1 is called yc minus y1. Similarly the distance between cz and centroid c2, the distance between centroid cz and c2 is yc minus y2. In similar way, xc minus x1 is the distance between centroid cz and c1, that is a horizontal distance. Similarly xc minus x2 is the distance between c2 and cz, that is also a horizontal distance. Okay, substitute all values in this formula, we will get the final answers, that is ixx equal to this value and iy equal to this value. So it is the final answer of area moment of inertia of an L section. Okay, thank you.